Welcome back to the tutorial series on LABVIEW for engineers. In this tutorial, I will discuss about repetition and loops in LABVIEW. So if you have ever programmed in any programming language, you might have probably wanted to repeat the execution of a section of code. In LABVIEW, we do it by two loop structures, for loop and while loop. So if you go to the functions palette in the block diagram and head towards the structure, you will find for loop and while loop over there. So let's put the for loop and while loop together and see the important elements of both of them. So we select the for loop from the palette and use the cursor to drag and form the for loop. So let's annotate it. It's for loop. And similarly, we can place a while loop and let's place it just beneath the for loop. So this is the while loop. So let's understand what are the important elements that need to be taken care of while we program anything inside the for loop or while loop. So if we see the for loop, one element is n. N is nothing but the count terminal. From here we control how many times to repeat the subdiagram or code inside the for loop. I is the iteration terminal. It tells the number of completed iterations. The iteration count always starts from 0. It is essential to remember that whenever the first time loop will start, the I will be 0. In the second iteration, I will be 1. In the third iteration, I will be 2, and so on. So it's always essential to remember this, that the iteration always start from count 0. Now let's come to the while loop. Again, the I stands here for the iteration terminal, and the other terminal here, which is shown by this red dot, is the conditional terminal. It controls the execution of the loop. The condition here right now is stop if true. So whenever true data is sent to this terminal, the loop execution will stop. We can also change it to continue if true. So if you go here and just click it, the condition now is continue if true. So the loop execution will only stop if the data going to this terminal is false. So essentially the difference in for and while loop is that for loop executes a set number of time which is decided by the factor n, and the while loop stops execution only if expected value of a conditional terminal exists. So let's take some example to understand working with loops in LABVIEW. Let's start with for loop first. So for now I will delete the while loop, and suppose I want to generate a series of 10 random numbers and plot those random numbers on a chart. So how I can do that? So first of all, I need a random number generator. So I can go to the functions palette in the numeric and choose random number and place it inside the for loop. Now because I want 10 instances of these random number to be generated, I want the loop to run 10 times. How can I do that? Is by connecting a constant with the count terminal, and the constant must read 10, which essentially is running the loop for 10 times. So now I want the random number to be plotted on the graph. So for that I can make a chart in the front panel, go to the controls palette, then graph, then grab a chart and place it on a front panel. We can rename it to something like chart for random number and choose the terminal for this inside the for loop and connect it with the random number. So now if I run the program, you will see something appears on the chart. So we can make it more visible by just reducing the x-axis to 0 to 20, because we are having only 10 instances of the random number, and we can also choose a plot with points. So it becomes more clear that we have plotted 10 points over a chart. To mention here, it is important to understand that the speed of the loop iteration depends upon the processor. So as fast as the processor computes, the loop iteration will be faster, or we have a higher frequency of iteration. But we can always fine-tune this by using wait functions. We can tell the loop to wait for a certain amount of time before executing the next iteration. So how can I do this? Is by going to the block diagram, then choosing the timing palette and wait function and place it inside a loop. So it has a terminal which says millisecond to wait, how many milliseconds you want the loop to wait before executing the next iteration. So I can make a constant here and say, let's say 500. So for 500 milliseconds the loop execution will block. So each iteration, the time difference between each iteration will be 500 milliseconds. So if I run the program, you will see that the chart will have a slow progress in plotting the points because the loop is slower than the previous one. Let's try to achieve the same thing of generating a series of 10 random numbers, but this time with the help of while loop. So let's see how we can configure the while loop to generate a series of 10 random numbers. So first let's remove the for loop. You can right click anywhere on the for loop structure and say remove for loop. So it will remove the for loop, and let's get rid of the timing structure and all the unnecessary items over here. Now we shall choose the while loop from the structures palette and drag it to encompass the program terminals. So as I have said earlier, the execution of the while loop is controlled by the conditional terminal. So by default the conditional terminal is set to stop if true. So we need to create a logic to end the loop execution when the loop has completed 10 iterations, thus generating 10 random numbers. So this can be done with the help of iteration terminal itself. Since the iteration count starts from 0, we might want to check when the iteration count reaches the value 9. So we can do that by comparing the iteration count to value 9. So we can go to the comparison palette, choose equal to and join iteration count here and place a constant here which will read 9. So what it essentially is doing is whenever the iteration counts to whenever the iteration reaches value 9, the program will send a true data to the stop function. So stop if true, whenever this happens, when I reaches 9 it's true, the loop will stop. So let's clear the chart from the data operation and try to run it. So here again we got the 10 points corresponding to 10 random numbers. So this I equal to 9 logic works when the loop conditional terminal is set to stop if true. What if the conditional terminal is set to continue if true? So if this is continue if true, what logic can be done here? So we can just replace equal to by less than sign. We can replace it by comparison palette and less than. So what it means now is whenever the value of I is less than 9, the loop will continue to operate, and whenever the value reaches beyond 9, the loop will stop. So essentially the loop will run for 10 iterations. So let's try to run it. So see, we got the 10 points of random number on the chart. Now let's talk about the situation when data needs to be passed in and out of the loop. For those cases, tunnels are used. Let's say we want to use the value of random number from last iteration and use it somewhere else in the program. So suppose I want to add 5 to the last value. What I will do is I will branch out a wire from the random number and drop that wire into the structure. So this will create a tunnel. Now there are a couple of options you may find for the tunnel. If you right click over the tunnel, you have tunnel mode, which says do you want to have the last value, you want to index all the values from the previous iterations, or you want to concatenate those values, or have a kind of conditional support to pass the data in and out of the program. So for my case, I will choose to have the last value. So I want to add 5 to this number. So I will choose numeric, place add, join it here, and I will create a constant of 5, and I can display this result in a indicator. I will say this is last value. Let's increase the access limit to 40 and Let's try to run the program. So the last value with the addition of 5 I've got 5.1714, and the value will be 0.1714 if you see on the graph. In the similar way, there are many instances when you want to pass data inside of the loop, so that could also be done with the help of tunnel. Now, apart from passing data in and out of the loop, we may also require to access data from previous iterations of the loop. This is done with the help of shift registers or the feedback nodes. To demonstrate how the shift register works, let's take an example. Let's clear the diagram. Let's take an example to find a factorial of a number. So just to keep in reference what we are doing, we are trying to find out factorial of a number. So to start with, what factorial mean is, we all know that factorial n means n into n minus 1 into n minus 2 up to 1. So for this, we may start with a for loop. So we can have a for loop, and how many times the loop should run depends upon the number itself whose factorial we want to find out. So we can have a control, we can create a control, and this control is our number, which will control the number of iterations of the for loop. So we can join n with number. Now the second thing is we want an indicator, and it should be indicating as what the factorial of this number is. So this is factorial. Okay, so what goes inside the loop? What should we do inside the loop to find the factorial of this number? So to start with, let's ponder about the iteration counter I. It starts from 0 and it increases up to the number of iteration loops. So what if I can add 1 to it? So I will increment this I with 1. So essentially I have just made it equivalent to the iteration number. If first iteration means now the value is 1, second iteration means now the value is 2, and this iteration value will go up to the value of the number, this, because this is number of times the loop will be operating. So now what I can do is I can place a multiplication operator, and I could imply that this multiplication should go on and on with respect to the previous iteration. So for the first iteration it is 1, for the second iteration it should be 1 into 2, for the third it should be 1 into 2 into 3. So all the previous iteration should be there. So for that I need something to get the data from the previous iteration. So here we use the shift registers. To create a shift register, you go onto the boundary of the loop, right click and add shift register. So here are the shift register. So what I want is, whenever I multiply, the multiplication should move to the from the end of this loop, should move at the beginning of the loop, and it should again be multiplied by the loop number, and this will give the factorial. Okay, so now if I want to find out the factorial of number 4, I will run the program, and so what else I needed is, since I have not initialized the value of this shift register, the default is 0, so it is multiplying by 0, so that's why it's giving 0. So I need to initialize it. So for initialization I can create a constant, and the constant should be 1. So for the first loop it is 1 into 1, for the second loop it is 1 into 1 into 2, for the third loop it is 1 into 1 into 2 into 3, and so on up to the number we want to find out. So for the number 4, the factorial will come out to be 24. For the for number 7, the factorial will come out to be 50, 40, and so on. So this is how the shift register work. So I will left you an exercise to try out how can we use a while loop to find a factorial. It would be interesting if you can come out with a solution with the help of while loop also. Now apart from shift register, there is one more thing which we could have used instead of shift register, just to take data back to the loop. So for that we have what we call as feedback node. So if I do not want to have a shift register, or if I have a very big lengthy block diagram where the wires are running from one corner to the other corner and it becomes messy to work out with, so I can just simply have a feedback node, and what I want to feedback is the multiplication, which is the answer, to the, and I will delete it, to the input of the multiplication. And I can just remove this shift register, so I can remove it, and I can again make a tunnel to join it. And the tunnel, this is the default tunnel is indexed, so I want the last value only. I put the last value, and for initialization I will have 1, so this is the initialization port. So now let's try to run it. Let's try to find out again the factorial of 4, it will come out to 24, and the factorial of 7, it will come out 50, 40. So in this way we have done a we have find out the factorial of a number, so with the help of shift registers or with the help of feedback nodes. So I will say the feedback node is a shift register in disguise, so you can try out both the ways. Obviously if you are having multiple operations going inside the loop, you may require multiple shift registers, and there may be a case when you require to have values from the previous iterations, maybe from the past 2 iterations or past 3 iterations. So in that cases we use the stacked shift registers. To see how this stacked shift register works, we take another example, and in that example we will try to find out the moving average of a random number. So we will start with a while loop, so create a while loop over here, and we generate a random number. So we go to the numeric, choose random number, and let's display this random number over a chart. So we make a chart, and I will say this is random number, and I will join these two. I want to find out the moving average of the random number from past 4 numbers. So I need to have the data from the past 4 iterations. How can I do this? Is first I will create a shift register, I will add a shift register, and now to add a stacked shift register which will have data from all the previous iteration, I will go to the left shift register and will add element. So I will add element, add element, and add element to have data from the past 4 iterations. So this will be, so these stacked shift register give the value from the previous iterations. The first stacked shift register gives value from the past iteration, the second one will give the value from the past second iteration, third one will give the value from past third iteration, and so on. So we are required to find the moving average of these 4 values. So as the loop progresses to one iteration to another, we want the mean of these 4 values. So for this, what we will do, we will first connect the shift register on the right with the random generator. So now the color has changes to orange, which means that these are real values. Now we will find the sum of all these quantities. So we have a numeric addition operation that we will have to do. So we will add these 1, then we will have another operation which will add these other 2. So we will join it like this. There is some problem, I think this is wrongly connected. Yeah, so now I will add these again to have the sum of all those 4 previous iteration values. So whatever the sum is, I want to divide it by 4. So I will go to the numeric, choose divide, and create a constant here, 4. So this will give our moving average. Now I want to display the result of the moving average in a chart, so I can grab this chart and copy it into, and I will connect this and I will rename this to moving average. So let's put these two side by side and let's run the there is some it is showing that there is some error. The conditional terminal is not wired, so we want the conditional terminal, we want some condition to happen. So let's say just simply I want to place a button, create a control, and this button, whenever I will press this button, the program will stop and the loop will stop executing. So let's try to run this. Okay, so it's really fast. We can add a wait function to see what is happening. So we can have wait function, we could have create a constant which says 200 millisecond, and let's try to run it again. So here on the left chart is the random number, and on the other chart is the moving average. You can see how smooth the data is. We can take any number of stack shift register to even more smoothen out the data. So we can stop the program by hitting the stop button and it will stop executing the loop. So this was all about the repetition and loops in LabVIEW and how we can control the program with the help of loop structures. I hope you have enjoyed it. Stay tuned, we will be coming out with next lectures on arrays and other structures. So take care and goodbye.